Alright, so this is problem 2, and it's very similar to the first problem. That we're primarily going to be calculating the change in internal energy based on how much heat and how much work occurs. All we have to do again is worry about the sign of Q, because there's heat, and if a balloon is heated by adding, if you're adding that much, the sign's probably positive. And if we're doing work on the atmosphere, it sounds like work is going out, so that value is going to be negative. And yes, we do just add them together. As for the rest of these, they're pretty straightforward. You'll notice that it's got this 10 gram idea going on here and a change in temperature. But for the most part, that doesn't matter. The only thing that matters is that the heat is 420, and I'll let you decide if it's positive or negative. And it doesn't look to me like there's any work being done here. Same goes in the last one. There's no work, so whatever change in E is, that is what, whatever Q is, that's what change in E will be as well. Watch out in here. I noticed that this one wants to be in joules, and that one needs to be in kilojoules. So make sure that your units are consistent. And lastly, just like in the previous one, you remember that when you're choosing whether it's endothermic or exothermic, it only depends on Q. You don't need to worry about what W is there. Just think about the sign of Q.